Yeah, so collections, as already we saw, like collections, basically it's a group of objects. So suppose if we have, if you create like 10 students object, and if you want to group together, or suppose if you want to pass them as one, like into any method, all the objects. So it's not good, like to pass. Just like this, like with the comma separated all the separate objects, so that we better create as a collection. So collection, if you create, there would be only one single object collection, you can pass that. The advantage with the collections, you can group all the objects, which are same category. That means student 1 to student 10 objects are belongs to student class only, so all are basically student related objects, so that we can group together as a collection. So we can create collection example with array list, like array list of student, list of student, and student list, array list, and we can add all the like 10 student objects here. Student one, two, three, like that. Okay, you can add a number of objects. And now we have a collection, student list collection, which holds all the 10 objects. So instead of passing like this, you can pass only student list. Okay, so it represents all 10 student objects. So that is the advantage with any collection. So if you compare this one, like we are passing like all 10 objects, and this one is only one object. That is the difference, right? So that's one example, simple example. And there are four types of categories in collections: list, set, map, and queue. List basically the list of things, and which allows duplicates. And set is basically does not allow duplicates. It maintains unique things. And maps basically, it is for key value pairs. And the queue is, it follows first in first out principle. That's about collection categories. So
So I
each
have a question.
yeah,
Can you go up a little, please, back to the,
yeah,
yeah, okay, here. When you write array list student, if you write here list student, that would be the same as array list. It would work the same way, right?
can you come again? I didn't get your question.
Okay. After you said array list,
Hmm. You are a
this
list.
angle bracket student,
Okay.
then stud list is equal to, right? So
Okay.
instead of array list, if you write just list,
Yeah,
angle
that will
bracket
work.
list.
That will work. The same as same.
Oh, okay.
Yeah, you can use even list also. There's no problem.
Okay.
Both are same. It doesn't change any
Yeah.
definition.
Okay.
This is the how usually in real time they use. Okay, so we can even use a list, no problem. Okay,
Thank you.
so yeah, so map. Now we have four categories: list, set, map, and queue. And out of these four categories, each category has multiple classes. Implementation classes basically. Map has hash map, hash table, tree map, and linked hash map. Set has hash set, linked hash set, and then tree set. List has array list, vector, and linked list. Queue, priority queue order. This queue we don't use much in real time, so no to learn, but we can just try with for sample example. And utilities basically collections and arrays. So these utility classes basically to apply any operations on the collection we get utilities. So that is suppose if you want to sort any list, ascending order of student ID or any sorting, you can use sort method is available inside collections and arrays. And if you want to convert collection to array, array to collection, so there are some methods available in these two classes only. So these utilities, why useful utilities? To apply any operations on the collections within the utility classes. And the legacy classes, there are five legacy classes. Legacy means like, the old Java one, like, from Java one, these are the five classes are available. So dictionary, hash table, property, stack, and vector. So these are carry forward from Java 1 to Java 8, no, Java 11. Okay, so the hierarchy already we discussed this. Collection has like super is in, this is all predefined API hierarchy. So this is standard one. We cannot change it because already Java engineers define this. We have to follow the same API hierarchy. And let's say a collections hierarchy. If you see, collection is the top interface. This has three child interfaces, which are set, list, and queue. Set has, this interface has some implementation classes like hash set, linked hash set, tree set, all these implementation classes are there. And list has array list, vector, and linked list. These are implementation classes. Queue has create queue and linked list. The linked list basically is a child for list as well as queue, because this is some different behavior, because each element linked to previous element and next element. That is the reason linked list is a child for these two categories. And map map has a multiple. The map, why they have given separate hierarchy, because map maintains the data as key value pairs. It doesn't maintain as list. So that is the reason map is different category, although different category of collection. So that is the reason they given in separate, the workflow separate hierarchy. So map has hash table, hash map, linked hash map, tree map, implementation classes, and object directly has array list and collections derived. Basically, so array list and collections are subclass of object. So that's about hierarchy array list. First array list, I think we practiced in last exam, last class. So I'll just go through theory concept only today. So other classes which we did not practice, I'll just make some programs. Okay? I'll practice some programs. So array list. Array list, it uses dynamic array of sorting elements. Basically, array list is one of the list type, list category type, and it used to add elements of very dynamically. So that is runtime it will allow. So it extends it extends abstract class and implement list interface. So array list can contain duplicate elements, and it maintains instruction order. So it maintains instruction order. It is not synchronized, and random access, because array works at index basis. Like basically it's a fast. Like when you an index basis means already we saw, like when we are trying to store the data, it stores as like when first when we define array list with some let's say string array list we defined here. So and when you're trying to add the strings here into this array list, what how it will store as indexes. That means first element is stores into zero index, start from zero, second index one, third index two. So in the same manner it will store the data. So that's why, like it maintains insertion order, and it's not synchronized. Synchronization is related to threads, so we'll cover later. So we can just think as not synchronized. Random access, because you can randomly access. That means suppose if you want to get like third uh, element or second element. Suppose second element you want to get, there's a get method. So if you look at this one, right, we're iterating. So we use the get method and try to access directly whatever the index element. Suppose if I want to, let's say I want to print John here only. So once we add all three elements, if you want to print John, what we can do, we can directly get this jam using the index 2, and when you say get out to, it will return this value, like, and then we can print this. So that is why it says, like, in the definition it says we can randomly access because it works with the indexes. And manipulation is add or remove is slow because lot of shifting need to be. Shifting means when you try to add new element, okay, and try to add new element, so it actually checks which order already was there, okay, it was already one. So it try to, like, find one position and add at last second one. So it more like, shifting is required. That is the reason it's not good for adding and removing. It's not good for adding and removing elements, and it's good for accessing. So in any application, if we have a requirement to add and frequently add and remove the data of array list, add and remove the data of list, basically array list is not suggestible. Then one more is the linked list. That is suggestible for adding and removing frequently the data. So this exam I showed, this example I showed in last uh, class. I think I sent all notes, right? Did any notes pending last two classes? I think I sent all of them.
Did you send it to me too?
Yes, yes, I sent you to.
Okay. Okay. Thanks.
This note we got it. Yeah, we got it.
The collections you got it, right? You also got it, collections.
The correction on the
Yeah. We got it.
we got the
Yeah,
the Zoom and the Zoom record and the note.
yeah, you can practice this. And linked list, so that is about array list. Array list basically dynamic array, and it follows like insertion order, maintain insertion order, and it's a faster retrieval array list. And linked list basically is a faster manipulation. Array list is not good for manipulation. That means adding and removing the data. Array list is not good. So now linked list. Linked list is also one of the list type. If you look at this chart, if you remember, right, this above chart. So inside the list, we have how many? We have array list, vector, and linked list. Okay, so now array list we already spoke, and now linked list I'm going through it now. So what is linked list? So if you observe this diagram, each element, okay, if you look at the second element here, B value is the B here. Second element linked to previous element and as well as next element. So for any node or for any element, if you want to know next element, it's possible with the linked list. So when we're trying to, like, add new element, it will just add it last. It doesn't even check, like, what are the indexes and all. It doesn't maintain indexes basically. So it just it will add linked list. So that's what linked list definition if you see. It uses W linked list to store the elements, and it extends abstract class and implements some list and DQ interfaces. So that's about linked list, and it can contain duplicate elements, same as list. It can have duplicate elements, and it maintains instruction order. So that is because when we add at last, we are only adding. So no random access. We cannot access any randomly the data because we have to actually get all the elements one after one. That means it's not good for retrieval, frequent retrieval. So manipulation is fast because no shifting is required. That means you can add and remove easily. So when you're trying to add, it will add last. When you're trying to remove, it will remove from beginning, like that way. You see, it will add and remove from one direction to in another direction, it will remove. So that's about linked list. So linked list basically, this also I showed. So in the live class, you can practice this program. Now, linked list and vector. There is a third type vector, so it is not given the document because that is not very important. And so there's interview questions are there. Next, I will walk you through even that. Then we will be good on the vector also. So then difference between list and set. So we have second category set, right? List, set, and queue. So what is set? What is the difference? So list can contain. So it says, like, list can contain duplicate elements, whereas set contain unique elements only. So that's the difference. So list will allow duplicates and set will not allow duplicates. That is the main difference. If someone, the important question, what is the difference between list and set? So you can say in that case, list can allow duplicates and set will not allow any duplicates. And has set. Has set is one of the implementation class. So what are the set classes? List classes. This chart you try to remember. Okay, this is important to remember this chart. So that if someone asks what are the list classes, array list, vector, and linked list. Set classes. Set what are the set class? Has set, linked has set, and reset. So each one has different meaning, like so we're going to talk. So list we spoke already, except variable vector. Vector is the same as like array list, and vector is basically not vector is synchronized, array list is not synchronized. Only the difference is that rest all same as vector. Sorry, vector rest all same as array list. So set has three implementation classes: has set, tree set, and linked has set. Map has four classes, which are hash map, hash table, tree map, and linked hash map. So and then queues has only one. So the chart you try to always remember so that you know what type of class you're talking. Okay, so now let's go to set. So if someone asks between list and set, now you know what was like list will allow duplicates and set will not allow duplicates. And has set. Has set is one of the implementation class for set interface, and has set internally uses hash table to store the elements and it extends abstract class and implements the set interface. And it continues it basically all the set behavior is the default behavior is it continues to have only unique elements. That is about hash set. Any set, if you take any set, hash set, tree set, so any set behavior is this a common, contains unique elements only, any set. And so what is the difference between hash set and linked hash set? We'll see, why they are given three classes. There is a purpose. So now linked hash set, if you see, so it contains unique elements only as hash set in the extends the same. So if you look at it, right, the contains unique element you will see everywhere. So and what is the specialty of this linked hash set? It maintains insertion order. So hash set doesn't maintain any insertion order. Linked hash set maintains insertion order. That means the set, right, when you're trying to add elements, so it maintains the same way how you are adding, it will display the same order when you're trying to display. So that is how it maintains insertion order. So suppose let's say you are adding one first, okay, you are adding two later, so it maintains insertion order. So because you added one first, right, and then two later, then three later, so then if six later, so it will store in the same way how you are adding insertion order. So when you're trying to print that linked hash rate, we will print the same way 1, 2, 3, 6 values, because it is basically the default behavior as linked hash rate is to maintain insertion order. So that's our linked hash rate. So hash rate doesn't need to be maintained insertion order. It actually it follows any order. There is no guarantee that it maintains insertion order only. Hash rate. So tree set.
Chandra, I have a question.
Yeah, yes, sir.
Okay, so since you said link has set, it maintains insertion order, which is the characteristic of list, correct? List also maintains the insertion order. List.
List doesn't maintain. Which list you're talking? List has multiple, right?
Array list,
Array
linked list,
list.
any list. List
No,
interface
no,
maintains. Yes,
no.
it does.
It doesn't. Who
It is
told
one
you
of the.
that? No.
Well, I tried it.
Okay, you tried it. Array list maintains insertion order. Linked has vector doesn't maintain insertion order. I think there's no guarantee. Even array list also no guarantee. Even it says array list maintains insertion order. I don't think linked list maintains insertion order.
So Chandra,
Okay,
I
so
mean,
what is the question now? Okay, assume that
question
it
is,
maintains.
my question is, so since list maintains the insertion order, what's the need of making this linked hash set? Because that's the same thing.
Look at this. Look at this.
Oh, duplicate. That's the difference. Okay.
This is the main difference. I told you right before starting. So this is the main difference. Okay. So that's why they have given these classes.
Yeah.
Okay. So linked hash set. Linked hash set maintains insertion order, and So, and liquid asset maintains instruction order, and hash set there is no guarantee that it maintains instruction order. Tree set actually same as linked asset, but the order, like these are all common behavior as maintain inequality. So if you look at right, so this is the for first asset, and linked asset also this is there. So uniqueness and tree set same uniqueness it maintains same as like but this is the difference, like maintaining ascending order, maintaining insertion order, it doesn't maintain any order. So tree set, what is the tree set? It maintains ascending order. That means if you try to enter some like first if I enter and tree set, suppose if I enter uh, 6 first, okay, if I enter 8 first, if I enter 1, so if I enter 10 numbers. So what order finally it maintains when you try to print, you will get first one is the first because it is a in ascending order, if you look at it, is the smallest number, and 6 you'll get it, 8 you'll get, and 10. So that way, like it maintains insertion order by default. So if suppose in your project, if a requirement like always my collection should be it should be sorted in ascending order. So then we can use this tree set. So if your requirement like always my collection should be in queue, as well as it should maintain ascending order, you can use tree set. If we have a requirement like if my collection should be always in queue, and it actually maintains instruction order, then you can use this. So if you just want to maintain eq order and without any like sorting guarantee or order guarantee, then you can use a hash set. Depends on the requirement. So now this actually the same as list. I actually let me practice. Okay, that's better way. Better I write some program. I thought of not writing, but since we have little time, I can write programs. Let me open this. Are you following, Slomit and you?
Yeah.
You are you following? Any question?
Yeah, yeah.
Okay, that's good. Okay, so linked list type practice. Now has set. So let me copy this. This email. Let's go. I'm importing this hash set on this. Control Shift O is the shortcut key for importing. So here, this is a hash set example. The main method, if you see, there is a hash set is declared with this like hash set. This is in Angular brackets like string. That means as I told right earlier. So string, it will allow only string, the values here inside the set. So and so string values. Suppose if you try to add any apart from like string, if you try to add any number, it will not allow because type safety. So it shows compilation error. So when any error, if you see, that's called compilation error. So it says like so the method add of string the type asset is not applicable for arguments int. So that's so that the way how we define declare the asset is asset, and then the set name, collection name, and the new asset has like constructor. So we can use that and create a asset, and then you can add same as array list. You can add the elements, and you can iterate in multiple ways. So iteration like using nested for loop, or we can basically use add all method also if you want, like add some other tree, some other asset, and then you can add it in multiple ways. This is one way. Let me put in another way, like so tradition, the classic for loop, like an initial for loop. So int I called 0 I less than set the size I plus plus. So basically, set doesn't have any what to say. It doesn't have any get direct method because set there is no random access. So we have to use the iterate from the other way. So one is this nested for loop. You can iterate, and suppose if you want to know any indexes under, like we have to use the iterate. So iterator how we can use set will have iterator as one of the method, and which returns here the iterator like so let me the iterator has nest and next methods. Has nest means so if uh, the iterator, so we can iterate until this one has this set has next value. So the has next means it will return true if we have already. That means, so here in this set, right, we stored 1, 2, 3, 4, 5, right? So first it will iterate set it will get the iterator. The iterator will give all these elements with corresponding like positions, and it will check. So first it will come here and check whether this one has next element or not. If it has next element, then it will go on like print using next using check. Iterate. So Okay, sorry. I think I have to get the iterator first. Okay, so now iterator. Iterator. So now I get the iterator. And using this iterator, we can next iterator. This one has next means it will give the object, like next means so if this has next will tell you like whether it has any next element or not. Next means it will print the object. So that's how with the iterator also we can parse the set and display the values. So let me put some SOP here. And let's run this code. So if you look at it, right, like we got values printed using advanced for loop, same value. If you observe hash set, it doesn't like sorted. So KPSR, so QRS, so there's no sorting order. So it randomly, like it doesn't maintain any order. So it randomly just prints the values. So now random is any other display. So if you look at right, so now I iterate the same value get displayed, and there's some other operations like there's one more set, tree set. There's a tree set example. So tree set example, if you look at it right, so hash set I just put this one for you to know, like there's another way to iterate and display the set values. So tree set. So we read right. So what is the tree set? Let me go to the document. Before that, let me check. 3 minutes left. So so tree set what we learn. So tree set, if you see tree set is maintaining eq elements and as well as it is ascending order. That means whatever the data we store into the tree set, it basically ascend into the sorting order. So now tree set I define here using the same way as hash set, using the same way as hash set. I define tree set now. So this is example for another collection which is tree set. And tree set I can add the same values like this. So now if you observe, RAM is added 2 times. So duplicate this. So it will remove the duplicates. And if you just set that add-on, and if you try to display right, so with this, it actually let me remove this add-on. Let's display. Okay, so now let's see. So we just declared like tree set as one of the collection, added all this. So now we are trying to show the tree set how it behaves. So as per the document, it has to show only unique values. So if you look at it right, so tree set data. If you see tree set data, how it is displayed. So it displays like unique values. So because I added 5 elements here, John, Ryan, Paul, Krishna, Ryan, but we got 4 elements. So because it removes the duplicates. And the order should be, since it's a tree set, order should be ascending order. If you do observe this data, right, J is the in alphabets, J is the first one. And then K is the second one, and P is the next one, R is the PQR, right? R is the last one. So it actually maintains ascending order. The tree set, we will look at linked hash set soon. Like when this meeting is ending in 1 minute, I'll stop here and send you a new link in 5 minutes. Is it okay? Hello?
Yeah, I hear you.
Yeah.
I'm
Yeah,
with you.
I'll send you new link in group. Okay, 5 minutes. After this
Okay.
recording is saved, I'll send. Yeah. Okay.